All right, recording started. So let's get started with the session, the 33rd Workplace NIAS webinar on Tuesday. So it's already too long we are doing this because of COVID online. But today we have a really special guest, Kip Opalfens from all the way from Belgium. And he's going to talk about Windows Defender application control in the cloud managed environment. And I know for a fact that a lot of people are very interested in this subject because a lot of companies are actually struggling with this. So really looking forward to this session. But before I hand over to you, I'd like to introduce also some other things we are doing, and we are looking for topics for the Ask Us Anything live Ask Us Anything from Ronnie and Franz, which we organize every month. So please go ahead to follow the QR code on the link in this deck and submit your session of your topics, rank your topics, and then we are happy to look for people who can cover that topic. Of course, we would like to thank our sponsors. Without any sponsors, we are not able to organize events like this. And luckily, we had an on-premises event back in November, and hopefully we will be able to do that again soon when the world opens up again. Follow us on social media, Twitter, Meetup, and all the other places. And for the upcoming events, in 2 weeks from now, we have the first live Ask Us Anything of this year. So submit your session or rank your session and then your session topic, and then we will fill that in. February the 22nd, we have Raphael Kölner going to share his thoughts about the community Microsoft Compliance Hero walkthrough. And then the 8th of March, we have another live Ask Us Anything. If you want to, or if you have a subject you want to talk about during events like this, submit your session and we will be happy to host you in one of the next sessions. So with that, I want to hand over to a good friend of mine, Kim Opalfens. Long time no see. Hopefully we see each other in May on the other across the pond, and then we can have a beer again. So yeah, couple of. I hand it over to you. Good luck.
Okay, so I start sharing now.
Yep. Take over.
Okay, so you should now see my screen. Feel it.
Yep, all good.
All right, so Windows Defender application control. This is me, as Peter already said, Kim Opalfens from Belgium. I tweet under the WMI guy, and for those of you already following me, you might have noticed that I've been somewhat invested in doing things with Windows Defender application control. As Peter and Kenneth, I've been an MVP for quite some time now. I've lost track of the number of years. I'm going to start off with setting expectations. The idea of this session is to set you up for success so you can start doing Windows Defender application control in a cloud managed environment successfully, which means I'll spend quite a bit of time in helping sell this to your company, or if you're a consultant, to customer companies, as to why you should have a serious look into Windows Defender application control. And what this session will not do is give you the entire deep dive and overview of everything related to Windows Defender application control. My colleague Tom and I have created a training of 20 hours of strictly content, no exercises within those 20 hours on Windows Defender application control. We have an hour and a half. There's no way I can cover all of that content in an hour and a half. All right. So what will we do? I'll start off with, as I said, the part of setting you up for success. I'll start off with helping you talk to other people as to why looking and investing time in Windows Defender application control is a worthwhile usage of your time / a worthwhile investment. Because that's often one of the very first things you need to do in any application control projects is you have to get the skeptics on board. There's a lot of organizations you'll go into that'll say, yes, I understand this will eventually be hugely beneficial from a security point of view, but this is not for us. We're too complex. This is going to take too much of our time. This isn't doable in our environment and things like that. Will be part of every single project you do around this technology for several years to come, I'm sure. Right? So we'll talk the what and the why initially. Right? And then I'll talk about getting started when you want to do this using Intune. Right? That's the topic we chose for today. This is specifically for customers that want to try and do this from within or for Intune managed devices. Right? And then we'll finish off the session with what I've called follow-up, meaning your initial policy is not going to be perfect. So you'll have to get your numbers of blocked content and blocked code down. So you need a way to do exactly that. I'm not going to spend too much time on the what is, but I'm going to introduce it anyway for people that might have not heard about Windows Defender application control. I typically call it the paradigm shift. Windows has been Windows for several decades now, and the idea behind Windows has always been you can run any piece of code written for Windows on Windows. There's no centralized store where you have to get all your applications from. You can basically take a USB stick, copy files onto a Windows machine, and basically run code. Self-written code, code you found on the internet, code that happens to be on the USB stick you found in front of the entrance to the building, whatever. By default, any code in Windows is allowed to run, which basically Tom and I use in a lot of presentations. Windows is jailbroken / rooted by design. If you compare Windows to an Android phone, an iOS phone, these devices can only run code from a store, or you have to jailbreak or root the device. Windows doesn't have that concept. So Windows is jailbroken from the get-go. That's the comparison, and it is what it is. What is Windows Defender application control? Well, it's this paradigm shift where you only accept code that you have defined as trusted code, which immediately means that USB stick you accidentally find in front of the entrance of the building. If you plug it in, well, any code on that USB stick will most likely not run because it'll most likely not be trusted code. that phishing malware in your inbox that launches when you double click it, it'll most likely not run because it's not trusted code. Right? And this goes on and on and on. An exploit will typically not run because it'll need custom code. Right? So that's the paradigm shift we're talking about. Right? If we look at some of the things that are being said around application control, well, the Australian Cybersecurity Centre, which is one of those organizations that typically publishes best practices and advice on what to do, calls application controls one of the most effective mitigation strategies for securing your systems. And the Windows 11 security book that came out basically says the same. Many organizations call it the most effective way of addressing threats. Same thing in the Windows 11 security book. One of the first steps to an effective application security strategy. So one of the benefits of Windows Defender Application Control, and one of the reasons I started looking into it, we'll get to another reason I started looking into it a little bit later. But one of the reasons is this. It's a very effective strategy when done right. And on top of that, just about every organization is already licensed to use it. Windows Defender Application Control is available for Windows Enterprise and Professional editions. So there's no additional license for you to buy to do anything with Windows Defender Application Control. You're typically already licensed for it. How many of you know this background screen? Well, maybe barring the green number that I tweeted out. If this was a live session, I probably would ask you to take a guess at what this number is. In online format, that is somewhat more challenging. If you think you know what it is, you can raise your hand though. That will give us some indication as to what people think it is. So I see a couple of raised hands. I'll explain it. It's a percentage. 91.50943% of all threats that are listed in Microsoft Security Center are blocked or at least impacted by implementing Windows Defender Application Control. And in that number, I've been very lenient towards campaigns that I consider not impacted by Windows Defender Application Control. There's a couple of credential phishing things that Windows Defender Application Control will not stop. There's an Exchange vulnerability that runs as admin, which would allow you to disable Windows Defender Application Control. But out of over 100 different campaigns that Microsoft has witnessed as malware campaigns, only 8 are not completely stopped by Windows Defender Application Control. Let that sink in for a while. There is technology out there that allows you to block just about well over 90% of all malware campaigns that are publicly seen by Microsoft. And Microsoft calls this threat analytics page their view on the security landscape. So they claim they see just about every attack, every large campaign, and this is the number of things we can just block with Windows Defender. So this is most likely a very good reason to start looking into Windows Defender Application Control. This one is as well. Microsoft has a presentation in which they call achieving over 90% of patch success of Microsoft updates, they call that world-class Windows monthly patching. So if you achieve over 90% of your patch rate in the first 14 days, that's considered world-class patch levels. Right? And I don't disagree at all. Right? But there is something to be said over that metric. Right? That means in those first 14 days, just about half or more of your systems are vulnerable because the vulnerability has already been disclosed. It takes hours, minutes after the release of a software update before exploits are being generated. And that's in the generous case where we're not talking about 0 days. 0 days before that, increase your exposure window. That means that even if you manage to achieve world-class patching, that your systems are still vulnerable 50% of the time. 50% of the time, your systems are not at the latest patch level, meaning they're vulnerable to whatever exploit has been publicly released. The only way to rectify that is to have something that protects you when you're not at that latest patch level. And that something is Windows Defender Application Control in my eyes. Because that means that even if the software update and the vulnerable code is released, before it can execute on your systems, they'll need a Windows Defender Application Control bypass on top of the exploit they've already found. So Windows Defender Application Control is the stopgap between the software update being released and you achieving great results in patch success. Windows Defender Application Control protects you in this time frame against all sorts of nastiness. All right, so that's the what and the why. I hope that was convincing enough, the short 10 minutes, as to why do I want to do this. Now, if you want to do this with Intune, there's some challenges in doing it right. And as it goes with Intune every once in a while, there's an abundance of different ways you can actually do this in Intune. There's 7 different ways at present in which I can actually distribute a Windows Defender Application Control policy. So the first thing on your road to success is pick the right way to deploy your policy. There's 7 different ways. There's one in the device configuration profile. That's probably the oldest option that Intune had for deploying Windows Defender Application Control. Interestingly enough, it is called Microsoft Defender Application Control. The feature has not been officially renamed to that because it only runs on Windows. There's no such thing as Defender Application Control for macOS at present. So it's still the Windows Defender Application Control. There's a second one in the endpoint security node of Intune. And then we have the administrative templates and the settings catalog that allow you to set a device a Defender Application Control policy. You can do it through a custom Homa Uri. You can do everything through scripts. So you can obviously do this through script as well. And then there's a new endpoint security application control node that is in private preview at present. And that's the different ways in which you can deploy a Windows Defender application control policy. And I've kind of listed them in order of preference. Ideally, you sign up for the private preview and you use that mechanism to actually start distributing your Windows Defender application controls. I've listed them all 7. There's a couple of caveats for a number of them. Right? So the very first 2 do not allow you to customize your policy in any shape or form. Right? They're basically built so that you use them in conjunction with what Microsoft calls the intelligent security graph, right? Which basically tells you, okay, you trust everything from the Windows operating system and all of this software that we assume is not malware. Right? And the intelligent security graph at that point in time makes sure that all software publicly known, like Office, Adobe, and stuff like that, is trusted. Right? The problem with that is your line of business application that everybody uses will most likely not be trusted by Windows because it's not signed by Windows, and it'll most likely not be in the intelligent security graph, meaning you cannot run it. Right? Trying to do Windows Defender application control without being able to customize your policy is next to undoable, and that's me putting it politely. Right? So options 1 and 2 basically are not usable. Right? Options 3 and 4, the settings catalog and the admin template, they allow you to reference your own policy and a path where that policy is stored. Right? Although that is workable, it means you still have to manage and distribute that XML separately through a different channel. Can be a software distribution, can be a script, but you'll have to both create a policy to tell the clients where the Windows Defender application control policy is, and you'll have to distribute it separately. Right? Which makes options 3 and 4 rather impractical as well. Right? Option 5 was the custom Homa Uri, which allows you to distribute your own XML and copy paste it in the custom Homa Uri. Peter van der Woude has a very good blog post on explaining how to do exactly that. There's a caveat in that as well. Any custom Homa Uri that you distribute, this is not specific to Windows Defender application control, any custom Homa Uri that you distribute has a max limit of 350,000 bytes. So 350 kilobytes is roughly what you can send out in one custom Homa Uri. Microsoft has something within Windows Defender application control that they call the recommended block rules. That's a list of files and rules that can be used to bypass Windows Defender application control. So deploying the recommended block rules is somewhat mandatory. If you don't, then publicly known bypasses for your Windows Defender application control policy exist. The Microsoft recommended block rules, though, is 111 kilobytes in size. And that means of the 350 kilobytes that you can use within your custom Homa Uri, about 1/3 is already gone in using the Microsoft recommended block rules. And that doesn't make option 5 unusable, but it does make it somewhat more risky in the longer term that you'll run out of space to distribute your policy. And then there's the horror story that a lot of people will probably find on the internet once you start looking into Intune and Windows Defender Application Control. Originally, Windows Defender Application Control was implemented through a CSP called the App Locker CSP. And Windows Defender Application Control, to be absolutely secure, originally had the great idea that if you made a change to a Windows Defender Application Control policy, whether you applied a new one or just made a change, every machine that received that policy would reboot within the next 10 minutes. It would forcefully reboot. So a number of people have been surprised that once they start playing with a Windows Defender Application Control audit policy, once they distributed that, all of a sudden, all machines within the organization started rebooting. That's typically enough to kill off your entire application control project for the foreseeable future. So whatever you do, don't rely on any of the Windows Defender Application Control policy options that require you to use the App Locker CSP. That means option 1 and 2 of the previous slide are no good and should not be used. So we end up with either script or the public-private preview. And if I take the public-private preview, once your tenant is enrolled in the private preview, you'll end up with an additional node called Application Control Preview. An Application Control Preview allows you to create your own policy, and you can distribute your own XML, or you can use the built-in controls and tell them what you want to do. Trust apps with good reputation means Microsoft has this database that you can talk to using the intelligent security graph and have those applications running. All right. Or you can trust the apps based on managed installers. And managed installers is something we'll talk about in the next couple of slides. Managed installers are one of those pieces of the Windows Defender Application Control feature that originally got me interested and invested into the feature. I see a question from Johan in using custom Homa URIs in combinations with supplemental policies. That's indeed one way of working around the 350K limit. So you could technically work around it that way, it's not hugely convenient to start splitting up your policy based on that, though. But yes, technically that would work. Now, the downside of using the private preview is that they deliver some sort of policy. So one of the things we've done is we've enabled PowerShell transcript logging so that we can actually see what Microsoft is doing if we use the private preview. What is the policy they actually distribute? And this allowed us to capture the detect and remediate PS1 that they use to implement this feature. What did that tell us? First of all, they create some dummy block rules for the managed installer. Managed installer technology is actually based on app locker functionality, interestingly enough. And app locker functionality, once you apply an app locker policy, you have to make sure that you create a policy for the exe and DLL containers. If you don't, then app locker has the nasty habit of just blocking everything. So that's what they did in their detect and remediate PS1. The other thing they do is once the policy has been implemented, they actually set a registry key that managed installer is enabled. So that's somewhat interesting if you want to see whether the policy has been deployed and managed installer has been made active everywhere. You can actually check it in the registry. And in the remediate, they basically create that same policy. They start some services and they merge the new managed installer app locker policy with an existing app locker policy if you already have one. Windows Defender Application Control comes with something that is called rule options. So the other thing that we documented in this slide deck is if Microsoft sends you a policy based on this new private preview, what do they enable? And they enable option 2 called user mode code integrity. For all intents and purposes, rule option 2 is Windows Defender Application Control. This is what blocks applications in user mode from running. We had a question around supplemental policies. Supplemental policies are relatively new. This allows you to create multiple policies and multiple policy files instead of one gigantic policy file. They enable unsigned system integrity policy. One of the interesting scenarios in Windows Defender Application Control is that you can actually sign your policy. If you do, then even a local administrator would not be able to remove the policy unless the administrator actually had one of the private keys used to sign the policy to remove it. Advanced boot options menu still allows you to boot in safe mode. We'll talk about rule option 13, managed installer, in one of the next slides. Rule option 16 is that option that allows you to implement a policy without rebooting. It isn't the 100% most secure way of doing it, but anything else basically kills the user experience 100%. So makes it unusable. And rule option 5, inherent default policy, is in there. We've added it for completion, but the interesting thing is rule option 5 is not actually implemented. There's nothing in the code that does something with rule option 5. What else is in there? Some additional code signers that are allowed to sign code so that it is trusted. They actually have the Windows RT certificate in there. The Windows Store certificate is in there. There's something called the Dynamics Code Generator that, for now, to be fair, I don't know what code is signed with that. And then there's a GUID with your own certificate. And tinyurl.WDAC Intune private preview, or PP, is actually a form you can use to sign up for the private preview that I've just shown you. If you're interested and somewhat serious in trying to do Windows Defender application control with Intune, I strongly suggest you sign up for that private preview to do it. If that's not an option, try looking into scripts, or if you have to use the custom Homa Uri with supplemental policies. Anything else is close to unworkable. Now, I've thrown this slide in between, because one of the other challenges you'll come around when starting to do Windows Defender application control is that you might have to start code signing things. In an ideal world, all vendors code sign their stuff, and you can rely on that signature. If 2020, 2021, and the start of 2022 proved anything that we do not live in an ideal world. And things haven't changed for code signing either. No, not all vendors code sign all of their binaries. We typically still run into anti-malware agents that have binaries that are not signed. So if the security industry doesn't sign all of their code, how on earth do you think that the rest of the applications out there are doing? So the unsurmountable challenge of code signing. In one single slide, the elephant in the room. This slide contains two PowerShell commandlets. Arguably, the one-liner on the last one-liner is somewhat long, but these two commands allow you to generate your own certificate if you don't have a certificate infrastructure to get one from, and sign a file in one single go. You generate the certificate once, and the bottom PowerShell command is what you need to start signing files. That's it. Code signing really isn't that hard. And having things code signed makes a huge difference in starting to build your Windows Defender application control policy. So that's why this slide is in here. One, to address the elephant in the room, and two, largely for reference for the commands that you need to actually start signing files. Now, policy building tips. So I've tried to put you on a way to success by one, selling the project as to why you want to do this. Secondly, I've tried to steer you away from any of the policy options that make implementing Windows Defender application control incredibly hard. So, as I said, go for the public-private preview whenever possible. That being said, the other challenges you're going to have is actually building your policy. Building policies for applications can be somewhat challenging. And our main way to remove that challenge is to not build policy all too often. The Windows Defender application control projects that we do heavily rely on technology that is called managed installers. If managed installers are not an option, we heavily rely on security catalogs. And if security catalogs are not an option, then we'll look into building a Windows Defender application control policy. But even if we build a Windows Defender application control policy, we'll quite often build it the exact same way. So I'll talk about our new WDAC policy PowerShell scripts afterwards as well. So what is managed installer? Any people in the session that have not heard of managed installer? If so, raise your hand and I'll explain it nonetheless. But managed installer is technology that makes sure that any application installed by your system's management solution is trusted by your Windows Defender application control policy. So that makes it hugely interesting to use in conjunction with Intune, and more specifically with the Intune management extensions. Because that would mean that anything deployed using the Intune management extensions would immediately become trusted. I assume most of you have read the small print by now. Managed installers unfortunately only work for applications that have been installed after the policy to define the managed installer was received by the client. So any applications already out there would not be covered by your managed installer. This is one of the reasons why I've tweeted out probably about a year ago that you probably should start deploying a Windows Defender application control audit policy towards your systems now. In doing so, you would define them as being covered by the Intune management extensions being a managed installer. So all of the applications you install at that point in time would actually be trusted. Managed installers have been around since Windows 10 1703, and that's about the point in time where I got interested in doing Windows Defender application control. They make life a whole lot easier and will probably become hugely important within your Windows Defender application control projects in the longer run. In the short run, however, you'll probably still have to come up with a way to make applications that have already been deployed to your clients trusted anyway. Which brings us to security catalogs. I think that's one of the things that we've started doing pretty soon in Windows Defender application control projects. And the interesting thing about security catalogs in Windows Defender application control is that everybody already knows them. Everybody has already seen these 3 screenshots of a security catalog on their Windows systems. Security catalogs or .cat files have been around for 2 decades and more. They've been used to make drivers trusted. And now they can actually be used to make applications trusted. So what we typically do in a Windows Defender application control project is we start making catalogs for just about every application that you deploy. Anything that you deploy through your systems management solution, whether that's Config Manager or Intune, we'll start building catalogs for it. And going back to the elephant in the room, we'll start code signing that catalog. In doing so, you make that application trusted. So security catalogs are a huge foundation to our entire user mode code integrity trust model. How do you make an application trusted, or how do you build one of those security catalogs? Ideally, you build yourself a system, a virtual machine, on which you can actually capture the catalog. Ideally, you enable Windows Defender application control in audit mode so that you equally capture temp files that are quickly created and deleted and might not be captured by the security catalog tool package inspector. Next, you run a command that is part of the Windows Defender application control feature set called package inspector. And the initial command says package inspector, start, and the drive letter you want to monitor. Next, you copy the source files of the application you want to install, Google Chrome. You install the application towards that C drive. You specify package inspector stop, -out, then the format, which is cat, minus name, which is the name of the security catalog you want to create. You sign that catalog, you copy the catalog to the cat root folder, and you're done. That's what it takes to make an application trusted. The benefit of using security catalogs is that, one, in contrast to managed installer, you're not limited to applications that are actually deployed using the Intune management extensions. This can perfectly be used to make applications trusted that have already been installed. And two, this is a very repeatable process. For Configuration Manager, we actually have this completely automated as an admin UI extension so that you can actually have the system generate these catalog files for you. Now, there are going to be applications for which you no longer have the binaries to actually install the application. Package Inspector actually has another switch called a scan switch to scan an entire folder and all of its subfolders for any of the binaries needed to be in the catalog. Once that's done, the rule is the same. You sign the catalog, you distribute the catalog for cat root to the cat root folder, and that makes the application trusted. Chances are that files are being used outside of the actual installation folder of that application, so you might have to create additional catalogs for these files. But that's about it. That's how catalog files work. And then we're into follow-up, tuning your policy. You've built your policy, you've distributed your policy, you've created the necessary security catalogs, signed them, and distributed the security catalogs. That's all nice and well. Now your applications are somewhat trusted. You can do this security catalog trick and the managed installer tricks for all of the applications that you know about. One of the big challenges that you'll come across in Windows Defender Application Control, and one of the things that you'll learn about your environment is that there's a ton of applications that you typically do not know about. And that's a pretty extensive percentage in our experience of the applications and the code that run in your environment. In most environments, we'll see several hundred of events still being created after we've built a policy and created the security catalogs for all of the applications that we knew were in the environment. So before you can actually switch to enforced mode, you'll have to know about the things that are still being blocked. And one of the challenges here is that Windows Defender Application Control somewhat lacks a management solution. There's no centralized management interface to do this follow-up. With the new private preview, there is somewhat of a management interface in Intune to distribute the policy and monitor whether the policy has been applied. There's no central follow-up into what is it that is still blocked in my environment, because you obviously need to adapt your policy towards that. Microsoft's official response to that centralized policy has been Microsoft Defender for Endpoint. Microsoft Defender for Endpoint actually centralizes the events that go into the local event viewer for Windows Defender Application Control. So all of that data gets centralized into Microsoft Defender for Endpoint, and quite recently Microsoft Defender for Endpoint received a new Plan 1, which is included in Microsoft 365 E3. Plan 2 has always been included in Microsoft 365 E5. Both of these plans allow you to centralize the events generated by Windows Defender Application Control. So that would make ideal candidates to actually check into, okay, so what is still being blocked? You could go into Microsoft Defender for Endpoint, use the hunting feature of Microsoft Defender for Endpoint, and start looking into the data as to what is still being blocked. That is a workable strategy, but it comes with an important caveat. One of the downsides of using managed installer technology is this. If you implement Windows Defender Application Control with managed installers, you'll actually see this in your app locker event log. So if you go to the exe.dll, you'll notice that a bunch of files are reported as being blocked. A lot of files in System32 are reported 3 times as a 2 times as a warning, 1 time as an error, that these files have been blocked by app blocker. I can assure you these are actually false positives. None of these files are actually being blocked. They're just reported incorrectly as being blocked. If all of this was actually blocked on my system would not be functional. These are false positives. The downside of these false positives, though, is that Microsoft Defender for Endpoint created a centralized log, but they tried to create one single log for both App Locker and Windows Defender Application Control. This means that all of this data pollutes your data in Windows Defender for Endpoint or Microsoft Defender for Endpoint, making it incredibly challenging for you to see what is effectively being blocked and what are the false positives for App Locker. So if I look at my Security Center, you'll notice I have a whole bunch of DLLs that have been reported as blocked, which theoretically would mean I have to start adapting my app control policy to make these files trusted. The only problem is I don't have to. All of these files are already being trusted. These are the files that are the false positives in the App Locker log. You might notice that they actually started and stopped on January 24th. That's because to be able to demonstrate this, I actually re-enabled the log on my system. Again, those of you that have been paying attention might have noticed that the exe and DLL log is actually disabled on my system. I don't need the App Locker log. I don't rely on App Locker to do my application control work. I actually rely on Windows Defender Application Control, which logs to the code integrity log. This is the information I'm interested in, not the App Locker bits. So one of the things to make the data in Security Center and hunting usable is to disable the App Locker exe and DLL logging. That way they do not pollute your data inside the Microsoft Defender for Endpoint hunting feature, and you can actually work with just the code integrity data. One of the other things we've been doing is our friends over at MS Endpoint Manager actually created a blog on how to centralize App Locker contents towards Azure Log Analytics. We've kind of took their initial scripts in doing this for Azure Log Analytics and App Locker, and we extended that so that we have that same data in Azure Log Analytics, but instead of using the App Locker log as a source, we actually use the code integrity log as a source, which allows us to have all of the data and just the code integrity data in Azure Log Analytics, and allows us to run our queries in there. Now we can start running our queries in there. We can work with workbooks and see what is going on. As you can see, we have an average number of events per computers that has been going up quite a bit. blocked unique processes per day in an environment that basically has information on the amount of processes blocked, where we can see that there's several hundreds of things being blocked a day, or even a couple of thousand a day within this environment. So there's a ton of things that you can learn by centralizing that information. Okay, so this allows you to do the centralized reporting bit, and that's one of the things you'll absolutely need to start tweaking your policy with the applications that are not being trusted just yet. And that's more or less the end of the presentation bit. The rest of the session is for you to open Q&A. Shoot me some questions. If you don't have questions immediately, that's fine. You have my Twitter handle at the beginning of this presentation. So if you have WDAC related questions, feel free to shoot them there as well.
Yeah, you can unmute or just the chat.
No, those notification WDAC blog post isn't ready yet, but I still actually have to write the blog. I can roughly show you how it works though. There's quite a bit of different things in here. First of all, it triggers off an event viewer event ID. Which is not something that is all too new. What might be somewhat special though is that I've created a custom event filter for it. So this is the actual query that goes behind it, because we didn't just want to trigger off one particular event ID. So event ID 3077 is actually the event ID for an application or custom code that has been blocked. The problem with just going for the event ID, which is way easier to build in a scheduled task, is that we were actually looking for processes that have been launched interactively. Because if you don't, if one single executable loads 7 files, you would see 7 those notifications, which is not a desirable user experience. So you might see that we actually filter on a number of processes called runtimebroker.exe. If you don't know runtimebroker.exe, that's actually the executable that is being used to launch applications from the start menu. And most of you obviously know explorer.exe, cmd.exe, or lower in the thing, PowerShell ICE and PowerShell.exe. So these are the different things that we use as a trigger on the event. On the action side, we actually run two different VB scripts. So a VB script that actually generates the toast notification, and a VB script that actually sends a Teams message. We use the Teams message and the Teams webhook to centralize the information so that we know, oh, something was blocked. We might need to look at what was blocked and potentially change our policy because somebody has been blocked. We use that to potentially adapt the policy or to contact the user and ask as to what he's trying to do to understand whether we need to add it to our policy or not. Quite often this turns into a conversation of, oh no, was just trying something, probably shouldn't have. Never mind, case closed. Trying to do something that they probably shouldn't have. We use VB script files because if you do PowerShell in a task scheduler, once you do PowerShell in a task scheduler, if it fires, it'll show you the PowerShell window briefly every single time. Even if you run PowerShell with hidden switches, and no matter what you try to do, the PowerShell window will flash by briefly. We actually use VB scripts to alleviate that. So if I look at the VBSs are incredibly simple. The VBSs basically just launch PowerShell after the VBS has been launched. If I open the WDAC team message.vbs, not sure how much you know about VBS anymore, but this is about what it does. It just runs PowerShell with a different PowerShell switch. And it runs the necessary PowerShell code to actually trigger the toast notification that I've shown on Twitter. That's roughly it. And all of this just runs in user context. You don't need special permissions to do any of that. And one of the other interesting bits that you might have noticed is that you can actually capture variables from the task scheduler. So I can actually get the event record ID, and we use that in the backend scripts to make sure that on top of just generating the message, I can actually tell you which process has been blocked and what file name it tried to load that wasn't blocked. So this results in something like Teams channel. So this results in messages similar to this. An application was blocked by WDAC, this computer name, this user context, this is the record ID, this is the process name, and this is the file name that was actually being tried to load. The VBS file can theoretically be blocked by an attack surface reduction rule, depending on what attack surface reduction rules you enable. It's not blocked by the obfuscated scripts one. It could be blocked by things that, prevalent and age kind of thing. what was being blocked initially was Martin's scripts to generate the dose notification. Because Martin, in his new dose notification script, actually generates dynamic codes to do a number of things. The dynamic code was initially not trusted, so we had to work around that a bit. You might have followed that conversation on Twitter as well. But that's briefly what we do with the scheduled task. And I'll share. I think the most interesting bits are probably our event scheduler query to figure out what the to filter what events we actually want to fire on. And the dose notification is indeed Martin Bexton's dose notification script. I know there's a couple of others out there, but his one integrates best with things like configuration manager and the PowerShell app deployment toolkit and things like that. So that's what we use. And the Windows 11 security book question has indeed already been answered by Sven. It's in the book that David Weston or Dweezil on Twitter sent out.
And I think Ru had a second question also about WinGet.
A question around WinGet. Do you think WinGet is secure enough as an app store? I probably would not rely on things like WinGet or Chocolatey as an app store for managed installer. I definitely would not make them a managed installer. You have to think long and hard whether you want to use those type of applications within your environment. If you look at the Chocolatey website, they specifically mention that you should analyze all of the scripts to see whether they're safe for your environment. I probably would okay using the sources for installation and avoid you doing the packaging. I would not make them a managed installer. Making them a managed installer just allows everything from those stores to be installed and to be used as a bypass for your WDAC policy. How does that work out with solutions as Capman and PatchMyPC? The benefit there is that I believe both solutions basically rely on the Intune management extensions. Right, so your goal has to be to initially create catalogs for everything that's already out there. But once you've distributed the policy that includes managed installer, then most of it should be handled by the Intune management extensions being a managed installer. Right? And that would make anything installed by Scapman and PatchMyPC trusted as well. Because how a managed installer works is as long as your process tree, right? So processes come in process tree with a parent process and a child process and a child process having yet another child process and so on. Right? As long as your process tree is in a process that is a managed installer, then everything written to disk by any of those child processes will be covered by the managed installer as well. Okay. So that's typically how most of the applications that are handled by PatchMyPC are handled. Right? The more annoying applications are self-updating applications. And that's typically somewhat more challenging. If you install Google Chrome and you let it self-update, your updated binaries will probably differ or be different from your security catalogs. So there's two schools of thoughts in solving that. One, stop applications from self-updating and start treating them as managed applications and manage the updates yourself. Two, create a policy that covers the current and future versions. But that second bit can be somewhat more challenging depending on how restrictive you want to be. Quite often you can actually get away with path rules that have been somewhat new in Windows Defender Application Control. Just specify the source folder, and that will probably cover the current and future versions.
But it's also a little bit of contradiction, allowing auto update on a fully managed lockdown device.
That's indeed one of the challenges. I see Kenneth has the app blocker question. They're separate things historically. App blocker has existed for quite a while longer than Windows Defender Application Control is. From Microsoft's point of view, App blocker, however, is a compliance feature, whereas application control is a security feature, which results in there's a couple of known bypasses for app blocker that Microsoft will not service. They won't fix it. So if you implement app blocker, no matter how well you implement app blocker, you'll need accompanying measures, or it can still bypass your app blocker policy. Windows Defender Application Control, Microsoft creates recommended block rules for any bypass they find, and if other bypasses are found, Microsoft actually serves Windows Defender Application Control. So that's a huge difference between both. One of the other huge differences between both is that app blocker allows you to implement an app control solution somewhat more granularly. As we've seen in my log, you can actually start by just implementing app blocker for exits. And you can later on start implementing it for DLLs on top of exits. And then you can start implementing it for scripts, which is one of the reasons why a lot of people will tell you that implementing app blocker is easier than implementing Windows Defender Application Control. I'll typically respond to that statement with, that's only true if you don't enable exits, DLLs, and scripts within app blocker. If you enable all three of them, you're actually doing the exact same thing as Windows Defender Application Control. And if that's what you're doing, then I strongly suggest you look into the newer technology that is actually being serviced as opposed to doing app blocker. And that doesn't mean that if you're doing app blocker, that what you're doing is not a sensible thing. Anything you're doing around app control is probably ways ahead of what everybody else in the industry is doing. I know, Johannes, you actually tried to distribute the XMLs from Intune and had some issues in app blocker. So yeah, it can be easier the other way around as well. But both are very sensible solutions. If you still have to start and you still have to build your knowledge, I suggest you do it on application control instead of app blocker. All right, that was a 5-minute question to a 5-minute answer to a 3-line question.
Alrighty. Well, I think Sven still has a question.
We don't have resources for automating the app trusting process for Intune just yet. And that's because of one of the challenges we have in doing this for Intune is recovering the installation sources. And there used to be a way to actually enumerate. Okay, you can obviously enumerate with graph all of the applications that exist in Intune, but downloading the sources for those applications is something that we no longer can do, which prohibits us from automating the solution end-to-end to create the catalogs for you. Somebody will have to provide us with the actual path to the installation sources and the command line being used. We can still recover the command line. We cannot recover the sources for now. We've mentioned this to the product team a number of times that this stops us from doing certain things, but for now, we cannot recover that content. That is slightly different in a config manager environment. There I can just see what share they used to store the files on and automate it.
Alrighty. If no other questions are here, let's finish. And let's take over the screen. So first of all, thank you very much, Kim, for your time and
You're very welcome.
I think it was a really good session. So hopefully people got everything out of it what they needed, and otherwise they know how to contact you if they have further questions or whatsoever. So thanks again, and thanks everybody for joining. Coming up next in 2 weeks, the live Ask Us Anything with Ronnie and Frans. Again, look at the URL we've shared earlier, and we will share this also under the YouTube upload, so that we can rate the subjects, and they can choose the best subject to discuss during that session. And again, thanks for all the sponsors, and thank you very much, and hope to see you in 2 weeks. Thanks. Bye.
Have a great time, folks.